All right, so imagine an AI that could see your entire health story. I'm not talking about just a single snapshot, but the whole movie, the complete narrative. That's the huge promise of what's called multimodal AI, a technology that's really aiming to completely revolutionize medicine. But is it actually ready for the real world? Today, we're going to dig into the incredible dream, the really messy challenges, and a surprising path forward that might just change everything. So, let's get into it. So to really get why this is such a big deal, we got to start with the problem it's trying to solve. And that problem, it starts with this number, 20 to 30%. Now, what is that? Well, that's the rough response rate for some of our most advanced revolutionary cancer treatments, like immunotherapy. Think about that. These are life-saving, absolute miracle drugs for a small group of people, but for most patients, they just don't work. And that brings us to a huge question.
I mean, if we have these incredibly powerful treatments, why is the outcome so often just a roll of the dice? This is the essential challenge of what we call precision medicine. And the answer, really, it comes down to the fact that we're just not seeing the whole picture. We're making these huge decisions based on a few scattered puzzle pieces instead of seeing the complete masterpiece of the patient. Just think about this for a second. Imagine you're trying to solve a 1,000-piece jigsaw puzzle, right? But all the pieces are locked in different boxes, spread out across different rooms. That's pretty much what it's like for doctors today. You've got a patient's radiology scans over in one system, their clinical notes in another, their lab results somewhere else entirely, and don't even get me started on their genetic data. That's in its own separate, locked-down file. So doctors are forced to make these incredibly high-stakes, life-altering decisions with, well, an incomplete view. And this is exactly where this new wave of AI comes into play. See, for years, the older, single-modal AI has kind of been like a detective with only one clue. It's fantastic at analyzing one single piece of the puzzle, like spotting a tumor on a CT scan. But multimodal AI? This is designed to be the detective who has the entire case file. It's not just looking at the image, it's also reading the radiologist's report, checking the patient's genetic markers, and understanding all the context from the clinical notes. And it's doing it all at the same time. So what's the end game here? Well, the ultimate goal is to use this AI to create what's called a health narrative for every single person. And this is basically a super high-fidelity digital twin of you, a living, breathing, dynamic model of your health that pulls together every single data point into one coherent story. Just think about the possibilities. With something like this, doctors could predict how you'll respond to a drug before you even take it, tailoring medicine in a way that, honestly, we've only ever dreamed of. It's a beautiful vision, isn't it? I mean, a future of perfectly personalized care. But, like any grand dream, it's not without its challenges. And in fact, when we pivot from that exciting vision to the actual reality of trying to implement this today, well, that's when things get complicated, fast. And this quote from Dr. Sharon Anger, a researcher at McGill University, just perfectly captures a fundamental truth about healthcare. See, this isn't just a tech problem, not just about connecting databases. It's a human one. Data is power, right? And it's so often trapped in these institutional and political silos, where just getting permission to even look at it can take years. Okay, but let's say you do it. You finally get through all that red tape, you get access to the data. What then? Well, the logistical hurdles are just immense. Dr. Anger explains that because of security protocols, they can't even use the cloud. So they're physically storing petabytes, that's thousands of terabytes, of information on actual hard drives. It's a total infrastructural nightmare that she compares to climbing Mount Everest, literally. But okay, let's just imagine for a second that you do all that. You climb that mountain, you navigate all the politics, and you finally get your hands on all this rich multimodal data. For years, the core assumption has been that adding more and more types of data, the images, the genomics, the notes, that this will automatically lead to better, smarter predictions. But is that actually true? Well, to answer that exact question, researchers set up a real-world test called the Chimera Challenge. They basically organized this big competition. They gave teams from all over the world this massive data set. We're talking pathology images, MRI scans, RNA sequencing, clinical data, the whole 9 yards, and said, okay, let's see who can most accurately predict cancer outcomes. And the results were absolutely stunning. In 2 of the 3 main tasks, the winning models, they ignored all the fancy, complex data. They completely threw it out. They won it by using only the structured clinical data, the clean, straightforward stuff like tumor stage, grade, and patient demographics. The simple, clean data absolutely beat the complex, supposedly richer data. This result is frankly a humbling reminder that in the world of AI, more is not always better. It turns out that all that messy, expensive, and computationally intensive multimodal data, it was often just acting as noise, not signal. It's proof that a smaller amount of really high-quality data can be way more powerful than a whole mountain of noisy, complicated information. So this is a real turning point, right? If the dream of one single, giant, all-knowing AI that fuses everything together perfectly is still out of reach, and hey, maybe it isn't even the best approach right now anyway, then what's the practical path forward? How do we actually start helping patients today?
Well, the answer might just lie in an approach called agentic AI. And instead of trying to build one giant monolithic model that does everything, think of it more like assembling a clinical A-team. Seriously. The whole idea is to create a group of smaller, highly specialized AI agents that work together, that collaborate, to solve a complex problem, each one bringing its own unique skill to the table.
So here's how that A-team could actually work in practice. You'd have one agent whose only job is to sift through all those messy clinical notes and create a clean, easy-to-read timeline. Then you've got another agent, your radiology expert, that analyzes the scans for key findings. A third agent is out there scouring the internet for relevant clinical trials, while a fourth is pulling the absolute latest research papers on the topic. And then finally, you have a summary agent that takes all that input from the team and puts it all together into one single concise report for the human doctor to review.
And see, this team of agents approach is so powerful because it bridges that huge gap we've been talking about, the one between the far-off futuristic vision of a digital twin and the practical, messy reality of healthcare today. It doesn't try to boil the ocean, it just breaks the problem down into smaller, manageable, solvable parts. What makes this model so promising is that it feels like it's actually built for the real world. By breaking down this impossibly large problem into smaller pieces, the whole system becomes more reliable and way easier to integrate into the tools doctors are already using every single day. The ultimate goal here is to give every single doctor, doesn't matter if they're at a top research hospital or a small community clinic, access to their own team of digital specialists. It's about democratizing expertise. And this leaves us with a really profound final thought. Maybe the future of AI in medicine isn't about building one single, all-knowing, almost godlike intelligence. Maybe it's about building a dedicated, specialized, and collaborative A-team of AI agents for every single patient, a team that works side by side with human doctors to write a healthier, more personalized future for all of us.